Can you see my screen now?
It's loading, sir.
Loading. Okay.
Now I can see your screen.
Yeah. Okay. So we can start now. Yeah. Fine. So last class I had given you an assignment to calculate the area under a curve by dividing the curve into successive trapezoids. Okay. Do I have that diagram somewhere here? Okay. Okay. So this you would have studied given a curve y is equal to f of x. Let's assume a degree 3 equation. Then you can calculate the area under this curve within the limits a to b. Okay, Tanmay, can you see this diagram? Tanmay, hello, Tanmay, are you there?
Yes, sir.
Can you see this diagram?
Yes, sir.
Okay, okay. So, given a curve, the question is to find the area under this curve given a limit a and b. Okay. So, what the method that we are using is called as the trapezoidal rule, where to calculate this whole area, what we are doing is we are dividing it into smaller trapezoids. Okay, each of having a base and a base length, let's say dx. Okay, they are dx wide. Let's say a to x1 is a dx. X1 to x2, again the distance will be dx. Okay, we choose some small interval, let's call it dx, because it's a small interval, we are calling it dx. And then by doing so, we are dividing this area into smaller trapezoids. Okay, trapezoid is one that has two sides that are parallel to one another. Okay. Uh, so by dividing this into smaller trapezoids, what we do is we compute the area of each trapezoid individually and then add them up totally to find out the total area under this curve. Okay, so we have to repeatedly perform this procedure. Okay, we have to create several trapezoids and repeatedly calculate their area, so for which we require a loop. So for our problem, we require the following data. We require the following data. Okay, so first one is if we have a degree 3 polynomial, then we require to know uh, the four coefficients. Apart from this, we also require the left and right limits left and right limits, A and B. And also we have to choose some value of dx. Okay. Hmm. Tanmay, can you hear me? ಇವಳಿಗೆ ಯಾಕೆ ಹಿಂಗೆ ಡ್ರಾಪ್ ಆಗುತ್ತೆ ಮಧ್ಯ Hello?
Yes, sir. I couldn't reply because the other system stopped working, so I had to log in with a different one.
Okay, now it's working, right?
Yes, sir.
Yeah. Okay. Okay. So I was talking about this trapezoidal approximation. Did you understand that particular part of trapezoidal approximation?
Yes, sir.
Okay. Okay. So we divide this area into smaller trapezoids, each of width dx. Okay. So for a program, we need to know what are the four coefficients, and then we also need to know what are the left and right limits a and b, and we have to choose some value for dx for our computation. Okay. So what we are going to do here is, so we will write one function def, okay, uh, curve area, which would require six parameters, c4, and c1, c2, c3, c4 are the coefficients, and a and b are the left and right limits. Okay, using this information, we should be able to calculate the area under this curve. Okay, we'll write the definition later. And within this, as you look at this particular diagram, we divide it into trapezoid. So we require one more function to calculate the area of a trapezoid. Okay, so def trapezoid area. Let's write a function called trapezoid area. So how do you calculate the area of a trapezoid? Any idea, Tanmay?
Sir, half into uh,
Huh.
half into uh, bre- uh, breadth of the trapezoid and
Huh.
non-parallel distance between the parallel sides.
That itself is the breadth, right? Distance between the parallel sides is breadth, then multiplied by
Uh, mm, the equal sides, length of the equal sides.
length of the parallel sides. Okay, sum
Yes.
of the parallel sides. So if you have a trapezoid, for example, as you see here, okay, let's consider the first trapezoid here. So the base is the distance from A to x1, and then this trapezoid has two sides. Let us call this height 1 and height 2. So we should know h1 and h2. So the area of this trapezoid is the average of these heights, h1 plus h2 divided by 2, multiplied by the base. Okay. So that is how we calculate the area of the trapezoid. So we need to know h1, h2, and the base. Okay, we'll again write the definition later. Next, let's have a main function which calls these two methods. Okay. So in main, we will read first. We need to know which polynomial we are calculating. So we will uh, read those input values C1, C2, C3, C4. Enter coefficient 1. Okay, likewise, we'll read the four coefficients C2, C3, C4. Okay, as input from the user. Okay. Next, we'll read the left limit. Enter left limit A, and then we will read the right limit B. Okay, so which is the limits between which we are supposed to calculate the area. Okay, so now we have all the required information. Okay, I will choose dx to be, okay, dx will choose in curve area. Okay, now we will calculate the total area by using this curve area to which these parameters are passed. Okay, whatever we read c1, c2, c3, c4, a comma b, all of these are passed as parameters. Using this, find curve area should calculate the overall area and store it in total area. Okay, then we will have a print statement. Print the area under the curve is total area, let's say units. This is the main function. Let's call the main function also. Okay, so main function, when it is called, it will read all these four inputs. Don't drop out. Okay. We'll
Yes,
read
ma'am.
this for four more coefficients. It will read the left and right limits. Whatever information we got, we are passing it on to the function curve area. Okay. So what you have to see here is main is not doing the computation. Instead, it is just sending the information required for the computation to the curve area. Curve area will compute and send back the results to main. Okay. It will be stored into total area. Okay. So now let's see how find curve area will be able to compute the result using these values. Okay. So let me choose a value called dx. Okay, we can decide on the size of dx. Let's say 0.01. Okay, let's choose dx to be 0.01. Okay, here we'll have a for loop or a while loop. Okay, whichever loop you want to choose. Okay, so I is equal to, so if we look into the diagram here, we should start from a up till the interval b. Okay, so for every value of a, I have to find out the trapezoid, calculate its area, and add it to the total area. Okay, so I will initialize I to A, and initial area. Okay, let me call this total area. Total area. Initially, we haven't computed anything. Total area is set to 0. Okay. While. Okay. So while uh, I is less than B. Okay. So we keep on shifting this I. Okay. I will be A initially. Next time it will be A plus x1. Next time it will be A plus x2 and so on. So A to x1 or x1 to x2, the distance is dx. Okay. So while as long as I is less than b, perform the following operations. Okay. So we will calculate the height one, or the x value. Mm, y1 is equal to x1 is equal to I, x2 is equal to I plus dx. Okay. So this will give us these values. Okay, initial x1 will be a, and then x2 will be I plus dx, which we will get as x1. Okay, next, now that we know the values of x at this point, okay, we have to find out the value y, where x is the value, x has this particular value, so we have to calculate it as y1 is equal to, we will apply the polynomial here. Okay, so our polynomial is coefficient 1 times x cubes, coefficient 2 times x square, coefficient 3 times x1, and c4. Okay, so we'll substitute in this polynomial for x, we substitute x1 to find out the first height y1 of the trapezoid. Okay, so for the very first time, I is equal to a. Okay, So x1 will be equal to a and x2 will be equal to I plus dx. Similarly, like how we computed for y1, substituting x2 into the polynomial, we'll be able to compute y2. Okay, so y1 and y2 are the heights of the trapezoid, and dx is the base of the trapezoid. So now uh, I will compute area of the trapezoid as area is equal to, here I am going to call the trapezoid function trap area to compute the area of the trapezoid. So what you have to see here is delegation of work. Okay, find curve area is not calculating the area of the trapezoid. Instead, it is asking the trapezoid area to calculate and return the result. It will store it into area. Okay, so trap area, I have to pass the heights of the trapezoid, which is y1, y2, and the base, which is dx. We have found out the area of a trapezoid. Okay, what we have to do, we have to add this area to total area every time. After you find the area of the trapezoid, add it to the total area. Total area is equal to total area plus the current found out area. Okay, then we have to update our I. So new I will be equal to I is equal to I plus dx. Okay. So when I update in the next iteration, I will be x1 and sorry, x1 will be here, x2 will be here. Okay. Likewise, we keep on shifting x1 and x2 and repeatedly calculate y1 and y2. Okay. Next, so when trapezoid area is called upon, trapezoid will compute the area as um, area trapezoid is equal to area of the trapezoid is equal to base multiplied by average of heights h1 h2 divided by 2. Okay, and after we calculate this, we return the area of the trapezoid. Okay, so this will be returned back. Whatever for trap area calculates will be returned back, and it will be stored here. Okay, so let's see if this program works. Okay, so enter the coefficients. Let's say 4x cube, 3x square plus 2x plus 1 is the coefficient. Let's say within the limits 2 and 5. Okay, what happened? Okay, I'm getting none units here. Oh, the reason was find area after calculating this result. Okay, it did not return it back. That's why I'm getting none. Okay, so outside the while loop, when while loop finishes execution, when I becomes equal to b, okay, when we reach the end here, we stop. Okay, so now at this point outside the loop, return the total area that has been calculated. Okay, this was the error. Let's rerun it again. let's take the polynomial to be 4x cube 3x square plus 2x plus 1. Let's say within the limits 2 to 5. Okay, so the area under the curve turns out to be 755.87. Okay, you can verify this by performing an integration on this equation. In the limits 2 to 5, it should be the same. Okay, so when you are given a complex problem, what you have to do is you have to try to break it into smaller modules. Okay, each module can be represented as a function. By doing so, we have reduced the complexity. Okay, we could have done this without using functions by doing computation everything at a single place, but that makes it more complex. So what we have done is, in main we have just made the job of main to read the inputs of the coefficients, okay, and the left and right limits. Okay, it will call upon the curve area function to find the area. After curve area returns the result, main will just display. So the job of main is to read the input, display the output, and call upon the function to do the computation. Main is not actually doing the computation. Similarly, computing the area under a curve, okay, that also it involves a small task of finding the area of a trapezoid. So that has been outsourced or given to another function, delegated to another function called trapezoidal area. So find curve area will not calculate the area of a trapezoid by its own. Instead, it calls another function. Okay. So what we are trying to do is we are trying to reduce the amount of work done by a particular function. Okay, by assigning part of the task to another function. Okay, this is called as modularization. When you have a very large task, instead of trying to do all the things by yourself, you can divide it into multiple people. Same in the case of programming, you can split the task across several functions and thereby get your task done. Okay, so this is how we compute the area of a curve using functions. Okay, any doubts so far, Tanmay?
No, sir.
Okay, is it fine? Okay, I will share the code. You can also run it for yourself. Okay, I can copy paste and run it later. Okay,
Yes, sir.
so this is the idea of functions. Okay, by breaking down a larger problem into smaller functions where a function performs a well-defined task. So in our program, you could see trapezoid area that performs a well-defined function whose function is just to calculate the area of a trapezoid, nothing else. Okay. Likewise, area under the curve job is only to do the computation of the area. Okay, it doesn't perform the input or output. Okay, so like that, we you can assign a specific functionality to each function and carry it out. Okay, another advantage of functions is that you can reuse them. Suppose you want to find out the area of another coefficient, all you have to do is pass you have to call the curve area but pass different values for the coefficients. Okay, and also possibly for the left and right limits. That way it will so you don't need to write again a separate code for another polynomial. Rather, you can reuse the same function, okay, and compute the area. So functions increase the reusability of code. You can repeatedly use the same code to perform multiple tasks. Okay, multiple similar tasks. Okay, so you can't make find curve area find out the area of a circle. Okay, it can find out only area under a curve, something like that. But for different polynomials, the polynomials need not be the same. Okay, they could have different coefficients, and also the area could be in a different interval a to b. Okay, so this is about functions. After understanding functions, the next topic that we are going to look into are the collections. Okay. So before discussing strings, Python has something called as collections or sequences. Okay. So far, we had dealt with entities like variables that could hold only a single value. Okay, we had seen integers, floats, all of these. Okay, though they could hold only a single values, but Python also provides us to store a set of values or a collection of values, and there are several yeah, features or several utilities available with Python that allows to store collections. Okay, so examples of them are we have strings, okay, we have tuples, we have lists, we have dictionaries. Okay, so dictionaries, and also we have sets. These are the Python's data collections. Okay, so it allows us to store multiple set of values. For example, I am performing uh, I'm performing a computation where I want to find out the average score of all the students in a particular subject. Okay, in that case, I want something that can hold marks of all the students. Let's say there are 40 students, then I require some kind of an entity that can hold all these 40 values. Okay, so I can't store 40 values into a single variable. Okay, I can write marks. So what I have to do is I have to declare 40 different variables, marks 1, marks 2, marks 3, mark 40, something like that, to store these 40 values. But that becomes cumbersome, writing 40 different variables. So instead, we can have a collection of values, a single collection that can hold multiple values. Okay, like I can write student score, I can create a list called student score. Okay, so there are several different types of collections that Python provides. Okay, so strings, tuples, lists, dictionaries, and sets, we will look into each one of them one at a time. Okay, so strings and tuples, these are called as immutable. Okay, whereas these are mutable collections. Okay, strings are strings and tuples are immutable collections. Means, what does this mean? Once you create a string or a tuple, its contents cannot be changed. That's why they are called as immutable collections. Okay, whereas in case of mutable collections, okay, their contents can be changed at a later point in time. For example, like I have stored all the marks of 40 students in say, a list. Okay, at a later point in time, one of the student finds that there is something wrong in his evaluation and his marks are re-evaluated, in which case his marks is going to change. Okay, so I should be able to store this change also. Okay, so for such cases, we require mutable collections. Sometimes we might be storing values that don't change. Okay, a collection of values that don't change over time. Then in such cases, we go for immutable collections. Okay, so Python provides two such immutable collections or sequences. Okay, they are also called sequences because they are a collection of values. Okay, sequence of values. So strings and tuples are examples of immutable collections. In today's class, we look at only the strings. Okay, so string is a collection of characters, often enclosed within either single or a double quotes. Okay, so a simple example of a string is t1 is equal to abc. So this is a string constant or a string, and this is being assigned to a variable called as t1. T1 is a variable, but it now holds a collection of values. Okay, for example, three characters A, B, and C. Okay, so let's look into how this work. Open your Python interpreter, Python shell here, and let's type P1 is equal to some sequence of characters. Okay. So we have created a variable T1 whose contents are a set of characters python. If we apply a type operation on T1, it should say that the type of data stored in T1 is of string type, str. Okay, so the new data type that we are exploring today is the string type. Okay, let me. Is the font visible now, Tanmay? Can you see it?
Yes, sir.
Tanmay,
Yes, sir.
you can see it, right? Yeah. Okay. So you can also open a term console, or within Spider itself you can run the same. Okay, here because it's appearing small, I'm using it here. T1 is equal to Python. Okay. So it is not that you have to use only double quotes. You can even use single quotes also. T2 is equal to, I want to create another something like let's say Java. Okay. So this is also another string, which is a set of characters JAVA. Okay, and if your string uh, exceeds a single line, if the contents are more than a single line, okay, you can even use triple quotes also. Okay, I think we will see that slightly later. Yeah, here. Okay, so let's take two strings as shown here. T1 is equal to contents ABC, BCD. Okay. So like you can perform relational operations, okay, such as T1 greater than T2. Okay, it gives us as false. So what happens here is when we compare two strings for greater than operation, it will compare first the first two the first characters in either string. Okay, so here the comparison is between the first character A in T1 and first character B in T2. In which case, okay, B has a higher ASCII value than A. Okay, and therefore T1 greater than T2 is false. If let's say I make T1 as ABCD, okay, and T2 still as BCD, but even then, if I say T1 greater than T2, it still says false. So what you have to understand is being greater than is not related to the length of the string. Okay, even though ABCD has a larger length, it has four characters compared to three characters to T2. T1 is still not greater than T2. Okay, it is with regard to the character mismatch. Okay, so if I have T1 is equal to ABCD, okay, T2 is equal to ABED, okay. Tanmay, tell me what would be the result of T1 greater than T2
False.
in this case? Why?
Because the greater than lesser than doesn't depend on the length of the string.
Huh, okay, that's fine. So both lengths are same, but why is it false?
Because
Why
T1 is
is
not,
T1 lesser than T2? What reason do you say
it doesn't have a
in this
value.
case?
They're alphabets.
Alphabets do have a value, okay? Uh, for example, okay. So if you want to find out the value for any particular alphabet, you can use the ORD function. Okay. So remember, everything has to be finally stored in the computer memory as zeros and ones. I can't store an A as a in the computer memory. Okay, I have to store it as a sequence of zeros and ones. So what they do for characters is, okay, for numbers we use the base 2 system and store them. So characters also are stored in a numeric form, okay, by assigning certain codes. So, for example, A has a code 97. Okay.
I want a pouch.
Likewise, capital A.
ನಂಗ್ ತೋರಿಸ್ಬೇಕು. Sir,
Hello.
can you repeat?
Yeah, you had some question.
No, sir.
Yeah. Okay. What I was saying was a character. Whenever you want to store a character, which is a non-numeric entity, A is not a number, right? So, what we do is we define a table. Okay, there is a mapping wherein for each character they assign a integer value. For example, capital A has the value 65. Okay. Capital B will have 66 naturally. Okay, because it is the next character and so on. And that will be till like Z will have a value 90. Okay. Then lowercase a has a value 97. Lowercase b will have a value. What do you expect the lowercase value of b to be?
98?
98, right? Okay, like that it will be in a sequence up till I think 132. Z will have a 122. Okay, z has a value 122. Okay, so capital A to Z will be 65 to 90. Small a to small z will be 97 to 122. And you might ask, what are the values 91 to 97, or values after 122, or values before 97? Okay. Apart from these characters, okay, we also have other characters. Okay, we have digits, we have special characters plus everything of them have a special value assigned to them. For example, I have the character digit 6, okay, which has a value 54. Okay, so 0 to 9 will also be in sequence. 0 will be 48, I guess. Yeah, 0 will be 48 and 9 will be 57. Okay, so for each character there is a particular value. Then for special characters, for example, the plus symbol. Plus also, if I want to store it into computer memory, it will be stored as an integer 43. Okay, so uh, what you have to understand is every character will be mapped on to a particular integer value. We typically call this value as the Unicode value. Okay, how to find out the corresponding Unicode value for a character? What you can do is you can use ORD. Okay, likewise, if you want to do the reverse of it, you can use the CHR. Okay, CHR of let's say 54. Okay, so CHR of 54 is, okay, the 54 is equivalent to the character 6. CHR of 65 should give me character A. Okay, capital A. 97 should give me lowercase a. 98 should give me the lowercase b. So ORD and CHR are complementary. Okay, if you want to convert a character to its equivalent ASCII value, you will use the ORD function. And similarly, if you want to calculate, you convert the ASCII to the character, you will use the CHR. Okay, did you understand these two?
Yes, sir.
Hmm? Okay, you can try out for other characters also. Let's say, for example, find out the ASCII value for letter T. Tell me what is the ASCII value for capital T. Which function you are going to use, ORD or CHR?
ORD.
ORD, right. So try it out. Tell me what is the value for capital T. While writing the character, you have to enclose them in single quotes.
So double quotes or single quotes?
Single quote, single quote. Double quote should do, but single quotes is preferable.
84.
Okay, let's verify that. Yeah, so T has a value 84. Okay, similarly, if I want to find out the equivalent value for, let's say, 103. Okay, what is the character equivalent for 103? Which function will you use?
Character.
Yeah, CHR function. Try that. CHR of 103. Which character is that?
1 second, sir. Oh, sir, it says error.
You should not use single quotes for CHR.
Oh, double quotes.
No, no, no double quotes. It is
Yes,
converting a number, so you have to give it in number form only.
G, small g.
Yeah. Okay. Small g. Okay. So what you have to understand is every character, okay, has an equivalent Unicode value, an integer value, which we call it as the Unicode value. Okay. So it is not only for English letters. Almost most modern languages also have their corresponding equivalents. Okay. I think even Kannada is supported. I have some examples later. Probably I will show you that later. Okay. Uh, so now coming back to our example, T1 is equal to ABCD, T2 is equal to ABED. Okay. So which of these two is larger, T1 or T2?
T2.
T2, right? Why is that?
Value of A, B, E, D would be greater than A, B, C, D because E is greater than C.
E is greater than C. Okay, so how it proceeds is it compares the first character. They are the same. Okay, if they are the same, it continues further. Again, it compares the second character, they are same. It compares third characters where they are different. And we see that whenever there is a mismatch, okay, so if the first character has a larger Unicode value, then T1 greater than T2 will be true. Okay, but in this case, E has a larger value than C. That's why T1 greater than T2 would be false and T1 less than T2 will be true. Okay, so if P1 is equal to ABE and T1 is equal to ABCD, which of these two is bigger among T1 and T2?
T2. T1, T1, T1.
Why?
Because A, B, C, D is greater than A, B, and E.
No. See, here we are not going to sum up the values. I said a string being larger than the other string is nowhere related to the length of the strings. Okay. So if I write T1 greater than T2, it still gives me false. Okay. T1 is not greater than T2, even though the length of T1 is larger. Okay. When it performs the comparison, okay, wherever the first mismatch occurs, okay, in that case, so here E and C is where the first mismatch occurs, okay, and it would stop comparing at that point and just compare the values of this mismatched characters. So it finds out that the character in T2 is greater than character in T1. Okay, E is greater than C, that's why it says T1 greater than T2 is false, or T1 less than T2 is true, meaning that T1 is lesser than T2. Okay, did you understand this part?
Yes, sir.
Hello.
Yes, sir.
Okay, so what we should be interested is the point at which the mismatch occurs. Okay, not the length. Got it?
Yes, sir.
So now let's say we have A, B, E, F. Okay, T2 is equal to A, B, C, D. Which one is larger among the two?
Uh, T1.
T1. Okay, why? Because A matches with A, B matches with B, E doesn't match with C. At this point, E is greater than C, that's why T1 is greater than T2. Okay, you can also perform a equality operation also. T1 is T1 equal to T2? What do you think would be the result in this case?
No.
Means false, right?
Yes. False.
Okay, so both these strings are different, that's why it's giving false. What about the inequality operation T1 not equal to T2?
True.
True. Okay, so you can perform all these comparison operations on two strings. Okay, and find out uh, which is the largest or the smallest. So the largest or smallest string doesn't mean that the largest string could have a larger string length. That need not be the case. Okay, it is about the mismatching characters. Okay, next we can perform some operations like length operation. Length of T1. Okay, it will return back number of characters in T1. Okay, so T1 has the characters A, B, E, F. How many characters? So four characters. So if you want to find out the length of a string, you can make use of the built-in function len. Len and then string parameter. It should give you the length of the string. Okay. Next, suppose I have a string S1 is equal to, let's say, Python. Okay, I want to access a particular character in the string. Okay, let's say I want the third character. I want to access the character. I want to fetch the third character. It is possible. Okay, so for this we use the index operator. You have to write the string name followed by square brackets. Okay, the square brackets is the index operator, and you have to specify a index. Okay, so I specify the index as 2. See, it fetches the third character. Okay, so this might be a bit confusing because when I say S1 of 2, I expected it to fetch the second character, which was Y. But however, indexing in programming usually starts from 0 and not 1. Okay, so the first index is 0. S1 of 0 gives me the first character E. S1 of 1 gives me the second character Y. S1 of 2 gives me the third character. Okay, so if I am supposed to fetch the fifth character, what index should I give? Tanmay,
So can you repeat your question?
if I want to fetch the fifth character in the string S1, what index should I give?
S1 bracket 5.
Look at the previous examples.
4.
Huh?
4.
Why is it 4? Yes, 4 is correct. Why is it 4?
First value will be 0, 1, 2, 3,
Yeah.
4, and
So
fifth value will be 4.
indexes start from 0. Okay. So if a string has n characters, valid indexes are 0 to n minus 1. Okay. 0 will fetch the first character, 1 will fetch the second character, and so on. So if I want to fetch the nth character in a string, the index should be n minus 1. Okay. So S1 of 4 will fetch me the fifth character. O. Okay. So this is how indexes work in strings. Okay, did you understand the idea of indexes? You want to fetch a particular character in a string, we make use of the index operator. Within the index operator, which is the square brackets, we specify the index value and it fetches us the index. Okay.
Yes.
Okay. Let's see another example. Okay. I create a string called as textual. I write I is equal to minus 1, and then execute this code. I minus is equal to 1. Okay. So what we have done here is we can use a while loop on this connection. Okay. Let's do this in a simple manner. While mm, let's say I we initialize it to 0, while I is less than it has 7 characters. When I is less than 7, print s2 of I and increase I by 1 every time. Okay, so when I run this, it fetches each character every time I is 0. Okay, 0 is less than 7. Okay, so print s2 of 0, it prints t. Okay, next s2 of 1, it prints e, s2 of 2, it prints x, and so on. Okay, s2 of 6 will print 7, and every time after printing we are incrementing the value of I. So I changes from 0, 1, 2, 3, 4, 5, 6. When I becomes 7, the while loop fails. Okay, 7 is no longer than 7. It stops, it comes out of the loop. Okay, so you can iterate over a string using the while loop. Okay, or you can even iterate using a for loop. Okay, so for loop has a simple syntax. For ch in S2, okay, we will take ch as a placeholder and then we write print ch. that will also do the same thing. Okay, here automatically it will keep on fetching one character at a time from the string s2. So first time ch will fetch the first character, next time the second, and so on. Okay, so this is how you can use loops on the strings. And apart from these indexes, Python supports negative indexes also. So, say suppose I have a string Siddhaganga as shown. Can you see this, Tanmay? Can you see this?
Yes, sir.
Yeah. Okay. So indexes I have written below them. Okay. One of the ways is the positive indexes start from 0. Okay, and they go up till n minus 1. This has 10 characters, so it is 0 to 9. There is an alternative indexing range wherein we can use negative indexes. So if I specify minus 1, it will refer to the last character. Minus 2 would refer to the second last character. Minus 3 would refer to the third last character, and so on. Okay. So if there are n characters in a string, the valid negative indexes are minus 1 to minus n. Okay. So that is what happened in here, over here. Okay. So I start with I being equal to minus 1. So if I print s2 of minus 1, it will fetch me the last character L. Okay, it is displaying L. I minus is equal to 1. If I subtract minus 1 from minus 1, I becomes minus 2. Okay, so which is greater than minus 7. So s2 of minus 2 will fetch the second last character, which is A. So this way it continues. Okay, when I is equal to minus 7, it will fetch the character D. After that, when I becomes minus 8, this condition is no longer true. Minus 8 is no longer greater than or equal to minus 7. It stops printing the values. Okay, so you can use negative indexes to traverse a string in a reverse order. Okay, so if you see here, the characters were printed in the reverse order. Now, can you tell me how you can print all these next to one another instead of being printed in separate lines? What
Um,
changes will you make to print?
uh, I don't
By
know.
default, print will add a new line at the end. Okay, every time print runs, it will add a new line. We have to change that behavior. So to do that, okay, so let's copy that code here. We will create a string, initialize I2 minus 1. Next, okay, here when I print s2 of I, okay, I will also say end is equal to null. Okay, nothing. By default, end would always be a new line character. That's why after printing every character, it prints a new line. It is going to print it in a separate line. Next, I minus is equal to every time reduce 1 from I. Okay, so this time, did you see textual was printed in the reverse order, and each character one after the other. Okay, without any new lines being added in between. Okay, so I print I minus, and then I will just put a empty print. So this will print a new line. Oh, okay, okay. I is equal to minus 1 S2 of I minus, and then it prints it in the reverse order. Okay, so this feature is only specific to Python. Okay, if you learn other programming languages, C, C++, and all, they support only positive indexes. There is no concept of a negative index available there. Okay, so this is a feature available only in Python. So strings can be enclosed either within single quotes or within double quotes or within triple single quotes or triple double quotes. Okay, so I can create a string by enclosing characters in single quotes, okay, or by enclosing within double quotes, okay, or if my string is exceeding, I can use triple quotes. This is a multi-line string spanning several lines. Okay. So to indicate the beginning of a multi-line string, I have to use three single quotes or three double quotes. Okay. And if you have used three single quotes, you have to use the same three single quotes at the end. Okay. So if I display S3 now, what you observe here, do you see the slash n in between?
Yes, sir.
Okay, so S3 is now a multi-line string. Okay, whereas S2 or S1 is just a single line string. So if I print S3, you will see it is split across multiple lines. Okay, this is A. After that, it prints a new line, multi-line string spanning several lines. Okay, you can even do the same. It's up to you to use either single quotes or double quotes. I write triple quotes, another multi-line string. Okay. So because we use double quotes at the beginning, I am using double quotes at the end. So S4 again will contain slash and in between. If I print S4, it will print this across multiple lines. Okay. So it's up to you whether to use single quotes or double quotes. And we also know when to use the triple quotes. Okay, triple single quotes or triple double quotes. Whenever you want a line to be spread across a string, a series of characters to be spread across multiple lines, we use this. Okay, usually these triple quoted strings are used to write the documentation for functions. Okay, then so S1 is equal to, let's say, something like this, Siddhaganga. Okay, so I can access the first character in the string. This is allowed. However, okay, I cannot modify the character at position 1. Okay, by saying change the character at index 0 to capital S. Let's say capital S. Okay, this is not allowed. Okay, it gives an error, type error. Okay, remember I said strings are immutable collections. Once they are created, okay, their contents cannot be altered. Okay, so trying to change a character in a string is not allowed. You can only access and display them, but you can't modify them. Okay, So this is another thing that you have to understand. Okay, so modification for a single character or a individual character in a string is not allowed. Okay, then you can suppose you have two strings. Okay, and you can concatenate these two strings by using the plus operator, a plus b. Okay, so it gives us a combined combined string, which is the concatenation of A and B. Concatenation is adding the contents of one string at the end of another. Okay, so you can even store it as a third string. I can write it as C is equal to A plus B. Okay, so you can see A is REF, B is ERENCE, whereas C is equal to A plus B, so it contains the concatenated string. Okay, so to perform concatenation on two strings, we make use of the plus operator. Okay. Another way to achieve the same is by using this tuple representation, but this is not commonly used. Okay, you can just write these two strings separated by a space within parenthesis. That will also get concatenated and stored into C. However, this is not commonly used, but this feature is available in Python. Okay, uh, the easier to remember is the plus. Okay, like when to concatenate two strings, I can put a plus operator in between, and the string concatenation is performed. Okay, then there are some special characters in Python. Okay, so slash n, we have already seen some examples here. Okay, slash n is for a new line, and sometimes I want to display, let's say if I want to write an equation a divided by b. Okay, let's say I create a variable eq is equal to a plus b. Okay, this is allowed. Eq will give me uh, this, but if I try writing a divided by b, okay, let's see what is the content stored in eq. Okay, it is something else. Okay, slash b is the backslash character. Okay, so it will not be stored as is. Okay, here I want these backslash to be literally written. I want it to be a slash b only. Okay, so for that, what I have to do is I have to escape the special meaning by putting a backslash before. Okay, two consecutive backslashes means a literal backslash. Okay, so EQ will be okay slash slash a backslash it into that job. No. A. Okay, I will get back onto how to remove, how to just store a single slash. Okay, then sometimes you would want to include a quotes in your string. Okay, for example, quote quote is equal to something. uh, Basavanna said work is worship. Okay. So if I display this quote, you can see that uh, I can have a literal double quote within the string. Okay, if you want to have literal double quotes, the whole string should be enclosed in single quotes. If I want single quotes, say if I want a single quote, if I include it in here, okay, see it gives us an error. So within single quoted strings, you can't have a literal single quote. Okay, rather you can have a double quote. So how do we solve this? So if you want a literal single quote, enclose that within double quotes. Okay, now it's not an error. If we print the string, okay, now I can have single quotes. If you want the double quotes, then we have to enclose it in single quotes. Okay, or another way is to escape the single quote by putting a backslash. So in that case also, it removes the special meaning of the single quote. So now you can use literal single quotes within single quoted strings also. Okay. So what this backslash does is it removes the special meaning and gives it a literal meaning. Print it as is. Okay. Don't treat the single quote as beginning of a string or ending of a string. Instead, just make it a literal character. Okay. Then okay. Unicode characters. You can even see this. Try this. So for Unicode characters, there are several ways of representing it. Okay, so when you use capital N, you can write the language and then the character's name. In this case, it is digit 5. Okay, let's see the content of num. If I print num, what do you observe? Do you observe the Kannada literal for 5 here? Is it visible?
Yes, sir.
Yeah. Okay. So you see that Python supports even local languages also, not only English. Okay, it supports major languages over the world. Okay, so if any language has a corresponding Unicode, it is supported by Python also. Okay, so there are different ways. One is the slash n notation. Okay, or if you know the value of a value of a particular thing in Unicode, okay, which is a hexadecimal value, okay, you will write slash u and in lowercase 0 cec. So then it will display that back. Okay, num is now, okay, cec is the 0 CEC. So this is hexadecimal CEC. This has the value equivalent to the Kannada digit 6. You can expect CED will have the value of the Kannada digit 7. Okay, so you can either write everything in lowercase or everything in uppercase. Okay, so in uppercase, you have to expand it such that it is of 8 characters. Okay, in lowercase, it will be of 4 characters in length. Okay, and you can also write the special symbols, like for example yen sign. Maybe the rupee sign is also having a unicode now these days, I guess. Let's see. Okay, no, rupee is appearing as rs. Okay, but the symbol also is supported. I think I'll find out and tell. Okay, dollar. All currencies are also supported. If I write dollar sign, you can see the dollar symbol. Okay, dollar, pound. Okay, maybe euros also supported. Yeah, you can see the euro symbol as well. Okay, so the thing is, Python supports Python strings support Unicode characters. Okay, so different language characters can also be displayed. So, given a character, how do I find its corresponding uh, Unicode value? I can use the ORD function. Okay, let's say Kannada digit val has the Kannada digit 8. Okay, so ORD of val gives me its hexadecimal equivalent, or the what is called as the Unicode value. For 8, the Unicode value is 3310. Okay, uh, Kannada digit 5, as we saw earlier, had the value C, D, and so on. Okay, then the reverse can be achieved by using CHR. Give some Unicode value as the input, 0xCEF, and find out what is the corresponding character. Okay, that's also possible. So CEF stands for the Kannada digit 9. Okay, and so on. Okay, so similarly, you could find Unicode characters for other languages also: Tamil, Telugu, French, German, whatever. Okay, so the next idea is of slicing and striding. Okay, so consider this string. We had learned so far indexing only, okay, fetching one character. So fetch the character at index 2 or the third character. So it is fetching me D. But instead of fetching a part of a single character from a string, okay, you can also fetch a part of the string, a slice of a string. That's what we call it as slicing. Okay. So to do that, yeah. So a general for structure for a slice would be of the format string name within the square brackets. I write a start index colon end index. Okay, so it will display all the characters starting with the index start up till end, not including end. Okay, let's try to understand this. So if I give s of 2 colon 5. So what is the start index? Start index is 2. The end index is 5. Okay, let's see what it displays. So it displays the characters starting with the index 2, okay, 3 and 4, okay, and it doesn't include the end index. So if I give start to end, it displays characters beginning from the index start up till end minus 1, not including end. Okay. Start 2 colon 5. So did you understand the idea of slice?
Yes, sir.
Okay. So you can fetch a part of a string using the slices. For example, uh, and these values of this start and end are not mandatory. So it is not that you have to specify both the values. Okay, even one of them could be absent. For example, if I write s colon 5, so in this case, if the start value is absent, it defaults to 0. Okay, by default, the start value will become 0. It is the same as writing 0 colon 5. Okay, you can see the same results. Okay, so if I want to just fetch this word Siddhaganga, tell me what is the slice I have to write.
Uh,
You can count and tell me what slice should I write within
One
square
second.
brackets.
Um,
Yes, how much? 0
one second.
colon.
Zero and the
See, you can look at the example 0 to 5. What did it fetch? It fetched
Z.
SIDDA.
Yes.
Huh. If I were to fetch this highlighted Siddhaganga, how would you do
Ten,
that? What value should it?
uh,
10.
10.
Yeah. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. It doesn't include the 10th character, which is a space. Okay. You don't see the 10th character or the character at the index 10. Okay. In a shorter form, I can just write it as colon 10 also. That would also do the same. Okay. So what do you understand? If start is missing, what is the value that it will assume? What is
Zero.
the default value? 0. Okay. Same way, if end is missing, okay. So I have written 11 colon and nothing. So end will assume the last character. Okay, length of the string. Okay. So when I said 11, okay, right from index 11, display till the end because colon thing is missing. Okay. I can even write what is the index of the last character here. 11, 12, 13, 14. Okay, 11, 14 will also give me the same result. Oh, sorry, 11, 15. Okay, 11, 15 will also give me the same result. Or another way, I can even write minus 1 also. Okay, but whenever we specify the end, it will not include the end but the previous character. That's why you are getting MUT. Okay, so if you want to take till the end, you just need to not specify the end index in your slice. Okay, so this is called as slicing. Did you get the idea of slicing?
Yes, sir.
Okay. So now run this and tell me what would be the output of 2 colon minus 3. Prior to that, write this s of 2 colon minus 3. Execute and let me know what is the result of it. Starting from the character that is at index 2, fetch up till the character that is at index minus 3 but don't include it. Okay. So which is the character at index 2 here in this example?
Uh, D.
D, right? 0 is yes, 1 is I, 2 is D. So starting from the D, display up till the minus third index. Okay, so which character is at minus 3? Index minus 3?
Minus 3 is uh,
The last third character.
U.
Which is the last third character?
U.
U. Okay, so up till U, but don't include U. Okay, so when we specify a slice, when we specify end value, the end character, the character at the end index will not be included. So it starts from D up till U. Did you see this? Okay, it started from D up till the minus 3, but not including the minus 3. Okay, so you can even write negative indexes as well. Okay, then if, okay, so this is an invalid one, not minus 3. Okay, if I write 1 colon minus 3, it will start from the second character and so on. Okay, so this is how you can use slicing in strings. Okay, then we can also like use negative indexes in start also. For example, 1, 2, 3, 4, 5, 6, 7. Oh, okay, late. Okay, so you can give negative indexes as well. So minus 7 is 1, 2, 3, 4, 5, 6, 7. Okay, the second D. Starting from here, go up till the index 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so up till G but not including G. So that's why we are getting this particular part. Okay, so this is how slices work in Python. The next part is, oh, okay, before we get to an example, okay, copy. Suppose we have this string, yes, and I write S1 is equal to yes colon 5 plus WO plus yes 5 colon. Okay, so S has the string postman, S1 will have the string postwoman. See, by using slices, we were able to create a new string. Okay, so what happened here is s colon 5 will fetch the first five characters. Okay, 0, 1, 2, 3, 4 post space. Okay, so this is what s colon 5 gives me. And to that, what are we doing? We are concatenating it with wo. So that gives us post space wo. To that, we are concatenating 5 colon, okay, which is man. Okay, so totally that becomes post woman, which is stored into another string s1. Okay, try running this code on your own. You also see it for yourself. Is the code visible?
Yes, sir.
Yeah, try running it on your own. See whether you are getting it. Did it work? If you're facing any issues,
One,
let me know.
no, sir. 1 second.
Yeah, yeah.
Mm, Sir, sir, it's showing a error.
Huh. Okay, well, what's the error?
Sir, I'm reading it was showing syntax error.
First, have you typed this part? So what you have to run is these two parts. Okay, don't try type this greater than symbols.
Yes, sir.
S is equal to postman. Is this giving any error? Post spaceman.
No, sir.
Okay.
I guess
After
it's
that,
yeah. This one. 1 second, sir. Let me see.
see whether you have typed it as is s1 is equal to s within square brackets colon 5, then plus within double quotes wo plus s within square brackets 5 colon.
Yes, sir.
Okay, is it giving an error again?
No, sir. I didn't complete it yet. I'm doing it.
Uh-huh. Do it, do it. So these triple greater than symbols are the prompt string. Okay, they are come automatically. You don't need to type them.
Yes, sir.
Okay, so now
I
are you
got. I
getting
got
it?
it, sir. Yes, sir.
Okay, so print yes. If you just print yes, it should give you postman. If you print s1, it should print you postman. Okay, so like this, you can fetch a part of a string using slices. Okay, okay. So we'll look into striding and probably okay wind up with striding for today. So striding extends upon slicing. Okay, so in striding we have three things: start, end, and also step. Okay, so slicing the step factor is by default 1. Okay, so step by one character each time, but you can change that. Okay, so say for example, okay, let's take the same example. Okay, I have the string, create the string. Okay, type the same string, and now I want to print every alternate character. Okay, 1 colon 9 colon 2 up till the index 9. Okay, then I can write it in this, start from index 1 and up till the index 9 print alternative characters. Okay, step count is 2. So it starts at 1. Okay, the character at index 1 is I, it prints it, and after that, okay, it moves by a step of two characters. So two characters after I, what is the second character after I in this example? After I, what is the second character?
Sir, after IDGN, we have
The second D. Second
second.
D. Okay. So after I, it prints the second D. See I D. After D again, the second character is G. Okay, A G. So it prints G. Okay. After G, the second character is N. Okay, and it will stop here because it exceeds this end limit. Okay, so we are supposed to go from 1 colon 9, means the range is 1 to 8. So 1 0 1 2 3 4 5 6 7 8. So it ends up in this range. Okay, after n, it tries to go two steps forward, it exceeds the range, so it stops. Okay, so this is how slicing works. So if I want to print characters at uh, let's say even positions, okay, so then I can write s colon colon 2. Okay, at position index 0, index 2, index 4, index 6, and so on. Okay, if I want to print characters at odd positions, okay, then I can say start from the second character, 1 colon 2 colon colon 2. End we have not specified. Okay, so here also if I don't specify start, it takes it to be 0. If I don't specify end, it takes it to the end of the string. Okay, in the second example, as I said, instead of starting at the first position, index 0, start at the second character, index 1. Okay, so it is printing characters at second position I, fourth position D, and so on. Okay, and you can use a different step also. You can say step at after every three characters. So it is displaying the character I. After that, the third character is A. After that, the third character is N. After that, the third character is space. After that, the third character is T. It is displayed this way. Okay. So you can use slicing and striding also in strings. And interestingly, you can reverse a string by using this method of striding. If you use the step count to be -1, okay, without specifying any start and end, it will display the characters in the reverse order. Okay, so Siddha Ganga Mat, if you want to reverse any string, okay, so if I have, let's say, another example, S1 is equal to some string, something like that. I want to obtain the reverse of it. S1 is equal to S1 is equal S1 colon colon -1. This will return give me the string in the reverse form. Okay, so this is the code to reverse a string, and then if I do s1 is equal to s1 colon colon minus 1. Okay, s1 double equal to, this will be true if the given string is a palindrome. Okay, or it will be false. In this case, some string is not a palindrome. Okay, suppose say I write s1 is equal to madam. Okay, so in this case, is this a palindrome? Tanmay,
Yes,
hello
sir.
Tanmay, are you listening? So
Yes,
is
sir.
this string a palindrome?
Yes, sir.
So now if we run this code, s1 double equal to reverse of s1, it gives us true. Okay, so s1 will give us the string, s1 colon minus 1 will give the reverse string, and we can compare them using the equality operator. Okay, if they are palindromes, it will return true. If they are not, it will return false. Okay, this is one way of using striding and slicing to obtain the reverse of a given string. Okay, see how simple yeah, it is to obtain the reverse of a string. In other languages, we probably should have written a while loop or a for loop and fetch the characters in the reverse order. We saw earlier also, like how to use the while loop to display it in the reverse order. Okay, this did it in a reverse order, but instead of this whole we can just do it by writing s2 colon minus 1. That will also give us the same result, give the reverse of a string. Okay, I think we will stop here for today. We will look into more features of strings in the next class. Okay.
Yes, sir.
Yeah. Any queries?
No, sir.
Okay. So how about tomorrow? Tomorrow, can we have a class tomorrow?
Yes, sir.
Yeah. Okay. Okay. Then we'll have the class at the same time. Okay. So we'll
Yes, sir.
stop here now. Okay then.
Thank you,
Bye.
sir.